Hello, today I talk about my senior design project, which is about feature selection and classification for pulmonary condition. Before start my presentation, I want to thank my laboratory friends Alperen Kavaklı, Arda Berat Köksal, Amru Veli and Salma Hasan. During this term, we worked three groups with each other at Biomedical Instrumentation and Signal Interpretation Laboratory, which is established by İpek. Asthma and COPD are a type of chronic respiratory disease which is difficult to define differential diagnosis because of overlapping symptoms. The objective differential method, which is spirometry test, isn't enough to define this differential diagnosis. However, in a previous study, which is done by İpek, shows that sounds from the lungs can be helpful in making a diagnosis more objectively than sounds that taken from the spirometry test. However, in this successful study, only one feature was used. At this project, we aimed at creating the best feature set which has best discriminative ability. In order to achieve our aim, we use feature calculation, feature selection, and feature classification algorithms. Features can be described as properties of data that help us to define differential diagnosis between COPD and asthma. In this study, we use 8 features which is extracted with 3 groups. We can explain feature selection as reducing the high dimensional data to the low dimensionality, and feature classification as classifies the data. There is a variety of selection and classification ways, but for this project we use K nearest neighbor classifier and forward selection method. The forward selection method starts with the null model, which means no variable. Then it chooses the most relevant feature. It keeps the first selected feature and produces a binary combination by choosing another related feature. After second iterative, it continues to third feature to produce a triple combination. The iteration process continues in this way until the best combination is formed. K nearest neighbor classifier is expressed as the classification of the data that has not been assigned to a class yet. By assigning it to the most ideal, most optimal class according to the distance calculated as a result of comparing the data of unknown class with the other data in the training set and performing a distance measurement. There is a variety of distance types such as Euclidean, Mahalanobis and Manhattan. But for this study, we use Euclidean distance, which comes from Pythagorean theorem. We'll start with the feature calculation. Before feature extraction, we divide our flow at 2 phases, which is inspiration and expiration. Also, we segmented these 2 phases with 6 subphases as early, mid-late inspiration and early, mid-late expiration. And then we start with the feature extraction, which is autoregressive model. Autoregressive model estimates the current sample of a sound signal by creating the linear function of previous sound sample. We can calculate the autoregressive parameter through this formula. The 2 parameters found here are very important for us. The first of them is order of R. In this research, we choose order of R as 6 due to our 6 subphases. The other parameters is the coefficient because this is this parameter that will make the differential diagnosis between asthma and COPD. If R parameters of asthma patients and those of COPD patients are different from each other, it may help us in the differential process. In order to understand difference between COPD and asthma, we use t-test. According to this test, we get the p-value. If the p-value is low, we can argue that the difference between COPD and asthma patient is high. If the p-value is high, the difference between them is small. In the color bar, we can see the p-value of 6 subphases and 14 microphons. When we look at the values, it is estimated that the first R parameter, which shows the smallest p-value, can only be used in the diagnosis of the disease in the early expression, which is the fourth phase. Due to the high p-value of the third R parameter, it is estimated that it will not help us in the differential diagnosis between these two diseases. Then we continue with another part of methodology of our project, which is selection and classification. Result of classification, we can see the maximum F1 scores up to each 6 subphase as early mid-late inspiration and early mid-late expression. Also, at final row, we can see the result of decision fusion. As we can see color bar, F25, F50, F75, which is extracted by Alperen and Arda, and third R coefficient affect in a good way from decision fusion. Unlike these features, bin for which is calculated energy value for third frequency band, which is extracted by Amru and Salma, affect in a bad way from this decision fusion. As we can see another plot, third R coefficient has the most discriminative ability to define differential diagnosis with asthma and COPD, with F1 scores 0.86 on 14-dimensional space because of our microphone. When energy value for different bands is added to our feature set, F1 score increase about 0.90 on 28-dimensional space. When another feature, which is bin 6 and maximum px is added, F1 score remains with the same value on 56-dimensional space. When algorithm find a last feature, it try to find it on 336-dimensional space. Our F1 score doesn't increase until we reach 6th feature. When we add 8th feature, it starts to increase about 0.91 on 72-dimensional space. The first 8 features in the table are my best feature set with 0.91 F1 score. The first 2 features in the table can be selected in order to reduce time consuming and eliminate the high dimensional space complexity that will occur in the system. Thank you for listening.